For thousands of years, the Sahara seemed untouchable. A sea of sand stretching for millions of kilometers, hostile to nearly all forms of life. But now, scientists are seeing the impossible. Patches of green spreading where there should only be dust. Less than 10,000 years ago, this place was lush grassland, full of lakes and rivers. Is it really possible that the world's most famous desert could turn green again? And if so, what does that mean for the rest of the planet? The answers start with living plants on the edge of the sands, and a mystery no one expected. Satellite sensors have been tracking the edge of the Sahara for decades, quietly recording changes invisible to the naked eye. In the data, a strange pattern appears. Millions of hectares around the southern border of the desert known as the Sahel are getting greener. MODIS and Landsat imagery, measuring the normalized difference vegetation index, reveal that since the 1980s, more than 50 million hectares have seen a measurable uptick in plant cover. But this is not a uniform wave of green. The change is patchy, stronger in places like Niger, Chad, and Senegal, where pockets of grass and shrubs have crept into land once lost to sand. On the ground, the story is even more surprising. In villages scattered across the Sahel, farmers describe trees returning to fields where nothing grew for years. Some remember when their parents cut down acacia and baobab for fuel, only to watch the land turn bare. Now, without planting a single seed, young trees are sprouting from old stumps and roots, reclaiming the soil. In certain areas, local herders have noticed new grasses supporting their livestock for longer stretches of the year. Scientists cannot ignore these signals. This is not the dramatic return of ancient rivers or lakes, but it is also not just wishful thinking. The numbers are real, the green is visible from space, and the people living at the desert's edge are watching it happen. But why here, and why now? The world's largest desert, long thought to be unchanging, is showing signs of life. The question is, why now, and what is driving it? Wind-scoured dunes and endless sand hide a different Sahara beneath the surface, a world that once flourished with life. Between 11,000 and 5,000 years ago, this desert was unrecognizable. Ancient lake beds, now dry and cracked, once held water deep enough for fish, crocodiles, and hippos. In the heart of Niger, archaeologists uncovered the site of Gobero, where monsoon rains exposed pottery, stone tools, and even human burials. These remains tell of people who fished in vast lakes and hunted along grassy shores. Across the central Sahara, rock faces are covered with carvings and paintings of animals that cannot survive in today's heat: giraffes, buffalo, and herds of cattle. Some panels even show human figures swimming, etched proof that water was once abundant. Paleolakes like Megachad and Fazan stretched for hundreds of kilometers, their outlines still visible in satellite images and ground surveys. Sediment cores from these ancient basins reveal layers of pollen from trees and grasses mixed with shells of aquatic snails and the bones of freshwater fish. For thousands of years, the Sahara was a green mosaic of lakes, rivers, and grasslands. Hunter-gatherers camped along the water's edge, leaving behind tools and ornaments now buried beneath the sand. When the rains finally faded, this world vanished in a geological blink. The evidence is everywhere, etched in stone, buried in mud, and scattered across the desert floor, reminding us that the Sahara's true nature is one of dramatic change, not endless emptiness. Earth's orbit is never still. Every 23,000 years, the planet's axis wobbles in a slow circle, a motion called precession. This gentle tilt does more than shift the stars in the night sky. It changes how much sunlight reaches the northern hemisphere during summer. When that tilt points North Africa closer to the sun, the land heats up more than usual. The result is dramatic. The difference in temperature between land and ocean grows, drawing powerful summer monsoon winds off the Atlantic and Indian Oceans. These winds carry moisture deep into the continent, turning the Sahara from desert to grassland. Scientific models show that during these high insolation summers, rainfall can double or even triple across the region. Rivers that are dry today would have flowed year-round, and ancient lakes filled to their brims. But when the axis swings the other way, the land cools, the monsoons weaken, and the desert returns. Paleoclimatologist Dr. Jessica Tierney describes this cycle as one of the clearest signals in the climate record. The Sahara's green and dry phases line up almost perfectly with this 23,000-year orbital rhythm. The evidence is so strong that researchers can match layers of dust in ocean sediments to the timing of these celestial changes. The physics are simple, but the consequences are vast. A slight shift in Earth's orientation can transform a continent. If orbital cycles drive the Sahara's transformation, the next question is, how do we find proof this happened in the past? The search for evidence begins in the sediments, the rocks, and the ancient lakes now buried beneath the sand. Deep beneath the Atlantic, layers of ocean mud hold the Sahara's climate history in fine detail. Each year, winds sweep dust from the desert out to sea, where it settles on the ocean floor, creating a natural archive that stretches back hundreds of thousands of years. Scientists extract long cylinders of this sediment called cores and analyze the thickness and composition of each layer. During wet green periods, less dust travels from the Sahara, leaving pale, clay-rich bands in the cores. When the desert dries, thick, dark layers of dust appear, sometimes shifting within the span of just a century. These transitions line up with changes in Earth's orbit, offering hard evidence that the Sahara responds quickly to even subtle shifts in solar energy. On land, ancient lakebeds like Lake Yoa in Chad tell a similar story. Cores drilled from the lake bottom reveal pollen from trees and grasses, shells of freshwater snails, and even traces of fish, clear signs of a wetter landscape. As conditions dried, these signals vanish, replaced by wind-blown sand and desert plants. Together, marine and lake records show that the Sahara's climate is highly sensitive to orbital changes, flipping between green and barren with surprising speed. Across the Sahel, ambitious projects are testing whether people can push back the desert's edge. The Great Green Wall, launched in the late 2000s, aims to stretch nearly 8,000 kilometers across Africa, an unbroken corridor of trees and restored land from Senegal to Djibouti. But the vision has evolved. Instead of a single line of forest, the project now supports mosaics of tree planting, soil restoration, and local farming innovations. In Niger, a farmer named Yakuba Sawadogo quietly pioneered a different approach. Starting in the 1980s, he encouraged his neighbors to protect the shoots that sprouted from old tree stumps instead of clearing them away. Over time, this simple method, called farmer-managed natural regeneration, restored thousands of hectares, and brought life back to exhausted fields, even as officials and neighbors doubted him. These local successes offer hope, but they remain small against the scale of the Sahara. Meanwhile, scientists point to another force at work. Rising carbon dioxide and warming oceans are shifting rainfall patterns, nudging the monsoon north. Human hands and global climate are now intertwined, each shaping the desert's uncertain future. Each year, the Sahara launches nearly 180 million tons of mineral dust into the sky. Trade winds carry this dust across the Atlantic, where about 22 million tons settle over the Amazon rainforest. That dust isn't just sand, it's loaded with phosphorus and other nutrients, feeding the Amazon's ancient leached soils. Scientists estimate that Saharan dust supplies up to a fifth of the phosphorus the rainforest needs to survive. But the journey doesn't end in South America. The same dust clouds drift over the Atlantic during hurricane season. As they travel, they block sunlight, cool the ocean surface, and dry out the air. Hurricane models and satellite records show that heavy dust years can reduce hurricane strength and frequency by as much as 30%. If the Sahara grows greener, dust storms will weaken. The Amazon could lose a vital nutrient supply, and the Atlantic might see warmer waters, fuel for stronger hurricanes. A shift in one desert sends ripples across oceans and continents, changing life far beyond Africa's borders. Earth's climate pulse is never truly unpredictable. Just one shift in the Sahara can ripple across continents. As the desert hints at change, our choices and emissions now help shape what grows or fades tomorrow. The world's largest desert reminds us, even the harshest landscapes are never set in stone.